Hello everyone, how are you doing? Okay, in this part we will be talking about the third part of our topic, in which we're talking about regression models. We previously introduced simple linear regression and then multiple linear regression. Today we will talk about still multiple linear regression, but in the case of introducing qualitative variable in the model. Now, if some of the variables that have an effect or that have a relation with the dependent variable are qualitative variables. Sometimes it's one or more variable. Okay, we still can deal with this situation and use regression analysis or use multiple regression model to represent the relation between the dependent variable and the independent one. So in this case, usually in regression analysis, we know that all variables should be quantitative, the independent variable and the dependent variable. Okay. And we saw in multiple regressions that I can have more than one independent variable, and they will be related or they have an effect on the dependent one. In this case, we're going to see that practically speaking or in practice, we saw sometimes that the dependent variable may depend on one or more independent variables that are qualitative. In this case, we still have a trick or we have a way to deal with this situation in order to represent the relation between the dependent variable on one side and all the independent variable on the other side using multiple regression. In this case, we will use what we call binary or dummy or indicator variables. So binary variables or dummy variables are used to represent a qualitative variable in a multiple regression model. The rule is if you use a dummy variable, okay, the dummy variable will take one of two variables, either 1 or 0. That's why it is called binary variable. So a binary variable or a dummy variable is a variable that will be introduced to the model. Okay, it will take either the value 1 or the value 0. And the number of dummy variables that you introduce in any multiple regression model will be equal to the number of the categories of the categorical variable that is introduced in the model or that is present in the data minus 1. Now let's look at our example. In our example, we said we have the real estate company. Okay, so we have the data representing the selling price, which is in dollar. This is the Y. And we said on the other hand, we have the size of the house, which is measured in square foot, and the age in years. And last time we talked about the relation, the equation of the multiple regression model that show me the relation between the selling price and both size and age of the house. Now, we have another column, which is the last column here. This column talks about the condition of the house. So the house could be in a good condition or in an excellent condition or in a mint condition. These are the three conditions of the house. Now, of course, if you think about what can have an effect on the selling price, of course, the age of the house will have an effect. And we saw this in the multiple regression model we introduced last time. Also the size of the house, and of course the condition of the house. So the price of a good house or a house that is in a good condition could be different than the one in an excellent condition or the one in a mint condition. So now we need to represent the qualitative variable condition and insert it in the equation. Yani now I need to have or to add other variables in the multiple regression equation to represent this variable condition, which is a qualitative or a categorical one. The rule is to define a number of dummy or binary variable that is equal to the number of categories of the qualitative variable present that is presented in our data set minus 1. Since the qualitative variable here condition has 3 categories, then we will be defining 2 dummy variables. I have 3, 3 minus 1 will be 2. So this means now that in my equation, I will have the first variable, which is x1 to represent the size, the second one, age, represented by x2. Now, since condition has 3 categories, okay, we will only be defining 2 new variables, which will be denoted by x3 and x4, and both will be dummy or binary variables. Now let's see how we can do this. We will start by defining x3, and as we said, every binary variable defined will have only 2 values. What are these 2 values? So now if you look at the first variable here, which is x3, here it is, x3 is equal to 1 if the house is in an excellent condition, and it is equal to 0 otherwise. x4 is equal to 1 if the house is in mint condition and equal to 0 otherwise. So this means now that the dummy variable that we're going to introduce to the model will be a variable that will take the value 1 if a certain category happens, and it will take the value 0 otherwise. In our case, the categorical variable is the condition. Since condition has 3 categories, okay, what we're going to do is to define 2 dummy variables, which are x3 and x4, okay, respectively to 2 of the categories of this variable. And the third one will not be represented by a dummy variable. That's why we said the number of dummy variable is equal to the number of categories minus 1. In this case, x3 will be equal to 1 if the condition is excellent and 0 otherwise. x4 is equal to 1 if the condition of the house is mint and 0 otherwise. Now we won't have any variable to represent the good condition, and the reason for this is very simple. If a house is not in an excellent condition, which means that x3 equals 0, and is not in the same time in a mint condition, which means that x4 equals 0. So if I have a case in which x3 and x4 both are equal to 0, this means automatically that it will be in a good condition. That's why we say that this category, for which we don't have any variable definition, is called an indicator. Why is it called an indicator? Because this category of the condition will be the category, okay, to which we're going to be referring the values of the coefficients of x3 and x4. Now, in a moment, this will be clarified a bit, but let's start with what is the rule of adding dummy variables to a multiple regression model. Whenever I have a categorical or a qualitative variable, okay, and I want to represent it in a multiple regression model, I will look at the categories of this variable, okay, and define a number of dummy or binary variables, okay, that is equal to the number of categories minus 1. In our example, we had 3 categories, okay, so we'll keep one of them, which is the good condition, and then we'll define x3 to be equal to 1 if the house is in excellent condition and 0 otherwise. x4 is equal to 1 if the house is in mint condition and 0 otherwise. And the category good will be what we call the indicator. Now let's move to the output of the model. So, as usual, when you look at the output of the model, in the output, if you remember, we said that we have mainly three parts. Okay, so here is the first part in which I can look at the coefficient of correlation and all of this stuff. The second part is the ANOVA table, and the third part is the part from which I can get the equation, okay, and I can do the individual test of the coefficients of the independent variable. Now, sometimes they don't come in this order. Sometimes this table comes in the beginning and the ANOVA comes at the end, and it depends on the software used. Okay, this example has been solved using Excel, so this is the order, okay, in which the output shows in Excel. Now the important first step, as usual, is to compose the equation. So let's compose the equation. How can I compose the equation? So it will be y hat equal to the y-intercept. So let's go back to the table. Here is the y-intercept. Okay. And then plus b1 x1 and then b2, which is the coefficient of the age, that is a negative coefficient, and then x3, which is the excellent condition, has this value as coefficient, and finally x4, which is the mint condition, which has this value as coefficient. Okay, so now this is our equation. Last time we talked about how to interpret the coefficient of x1 and x2. Now let's move to the new part, which is what does this